Hi everybody. In this video I want to talk about some number patterns where we're going to look at the subscripts. That's the little tiny number you see here. That's the subscript. We're going to look at the subscripts and see how the subscripts help us see a pattern. And then we can use that pattern to predict a new one where we don't know the answer. This will help you with the Fibonacci problems on the project. It will help you with the pentagonal numbers problems, triangular numbers, anything that has subscripts. So here we go. Let's look at the first pattern. If you look at this first pattern, you see it goes 1, 2, 3, and then 5. Now you're pretending there's some numbers that each of these is equal to. I'm going to call them the circular numbers. I have no idea what that means. I made it up. Okay? But in my world, the circular numbers always do this. You add one, the first one, the second one, and the third one, and you always get the fifth one. The pattern here is very similar to this one. You add the third one, the fourth one, the fifth one, and you always get the seventh one. Now, you might see a pattern going down, right? I've got 5 and then I've got 7. But I skipped the next line, so you can't do that pattern. I skipped to several ones later. So that instead of looking down, I want you to try to look across so that when I give you one you don't know the answer to, you can find it without having to do all of these examples. Take a long time. So let's see how they're related. Well, I see this one is 1 and this 2 is the next one. And 3 is the next one. And that's true here. 3, 4, 5. Those are the next numbers in a row, right? We call that sequential numbers or numbers in order, right? So I could say, oh, look, they're always in order. Or I could say, look, they skip every one. But that's not the pattern you're going to be asked about. You're going to be asked about the answer here. How does the answer C5 relate to these guys? So I go 1, 2, 3, and then I get 5. So how much did I skip? 1, 2, 3, and then 5 is not the next C number, the next circle number, whatever that is. How many away is it from C3? It's the same thing happened down here. It goes 3, 4, 5, and then it skipped some and it goes to 7. Is it the same amount away from 5 to get to 7 as it was up here? Is it the same amount away here to get from 10 to 12? It is. How far away is it? So if you want to predict, like if I give you these C numbers, you can say, all right, I want to predict this. I don't know the answer, but I want to make a prediction. What if I had C17, 18, and 19? How could I predict what the answer would be just looking at the other ones? Well, I could say it looks to me like the answer number is always 2 away from the last one. So if I had 10, 2 more gets me to 12. 10 plus 2 is 12. So I'm going to go 2 more from 19, 20, 21. It's got to be C21. And that's the idea of using this pattern going across to find the new one. Now in this one, we're going to go even a little further. So you might want to take a break if you feel like, oh, I just finally got something. Take a break, maybe do a couple of the Fibonacci ones that relate to that pattern 1. And then when you're ready, start the video again and listen to pattern 2. So pattern 2, we're going to actually move into algebra with it. So I invented some new numbers, Y2, whatever that is, yellow numbers, M3, mean numbers, I don't know. If I add Y2 plus M3, I get Y4. If I add Y3 plus M4, I get Y5. Y4 plus M5 and I get Y6. So you can start to see how these numbers in here are related to each other. If I go from 2 to 3, that's 1 more. And if I go from 3, the next one is a 4, so that's 1 more, right? Think about what we just said. One more, one more, one more. So how would I write one more in algebra? That's the big question. And how would I do one more if I had a whole new set? So if I had a set that started with 7, what would be here with the M and what would be here with the Y? Well, I know I added 1 from 7, so here would be 7 plus 1. Let me make it into subscript. So this is our little subscript, and it's going to be 7 plus 1, or 8, right? So one more, because this one goes from 4 to 5. One more. And this one would be 7 plus what? How many more would I need to go if I started from 7? So look, if for a hint, see how here I started from 4? What do I need to do to get to 6? 4 plus what gives me 6? 4 plus 2 gives me 6. So to imitate that pattern, it would be 7 plus 2. So it would be 7, 8, 9. But that time I started with the 7 as I'm thinking about it, right? Because I want to change it into algebra. So here, to change it into algebra, whatever I did to the 7, I'm going to do to n instead. Basically, I'm just replacing the 7 with an n. My goodness, it's like magic. Now, with this one up here, with this, I could actually get the answer, right? Which I didn't do. I could say, okay, I know 7 plus 1 is 8. Whoops. And I know 7 plus 2 is 9. I could actually get the numbers, but here, using variables, we can't. We can't get the numbers here. We don't know what n is. N could be any number, right? Any whole number. It's probably just a whole number. So maybe n is 4. Let's test if our formula here is correct by putting 4 in for n. So I'm going to copy my formula. And remember how I made the formula. I made the formula looking at this line here, going, whatever I do to 7, I'm going to do to n instead. So I put n where the 7 was, right? So now I'm going to say, okay, if n is 4, will it work? I get 4. 4 plus 1, I'm just putting 4 in for n, and 4 plus 2. So 4 plus 1 is 5, here's 4, here's 5, and 4 plus 2 is 6. It worked to get me this example up here, 4, 5, 6, so it works. And you do want to make sure of that with any pattern that you do. And one more time, remember that we got n plus 1, n plus 2, by looking at how the three numbers are related, starting with the first one, which was 4. Let's look at, you might want to stop the video for a second and just think about that, pause it before we go to pattern 3, so that you get to think, replay, redo. Okay, once you've thought about it some more, here's pattern 3. So pattern 3, I want you to notice what's the same with this number and which one is different. And how different is it? So which ones are the same here and which ones are different? And if I wanted to imitate this with a different number like 12, if this one is 12, this one should also be 12 because the subscript on the C and the M are the same. Well, and then how would I figure out what this one is? It goes 8, 8, 7. It goes down 1. 6, 6, 5. It goes down 1. So 12, 12, it's got to be 11, right? So now mentally, what you did to the number, you're going to do to n instead. And this time I'm going to skip the step where I wrote it out as plus signs, because for some people that step is confusing. So if I make this one an n, that's like my 12. This one is the same number, so it has to also be n, my 12, right? If this one's 12, that one's 12, they have to be the same number. This one is 11. It is 1 less than 12. So this has to be n minus 1. The step I skipped is where I write in, starting with 12, what I do to each one. And in case that's a step that helps you, I'm going to do it now. But it might not be. It might be a step that's confusing for you. So what did I do? Here's 12. Here's 12 plus 0. I didn't add anything to it. And here's 12 minus 1. I subtracted 1 from 12 to get 11. And let's see, yep, this imitates that. N, that's my 12. N plus 0, but that's just n. N plus 0 is n. And then n minus 1, 12 minus 1. So that's how I want you to start thinking about the patterns. Oh, and we can check it. If I want to check that my pattern is correct, I can pick any number I have already seen in the patterns for n. So like I could pick 8. Let's let n be 8. If n is 8, I put 8 there. N is 8, so I put 8 there again. And then 8 minus 1, right? I put 8 in where the n is. 8 minus 1, 7. Did it work to get me that first one? It worked. So my pattern is correct. So I hope that helped. You can now do a whole lot of problems on the project.